In this video, we'll be graphing quadratic functions that are written in standard form and then identifying their key components. So here you can see standard form, and a couple of things I want to hit on with standard form is that this is the form where we have all of the parentheses gone and everything's multiplied out with like terms combined. And this will be written in the form y equals ax squared plus bx plus c, where a is this coefficient of x squared. Then we have the b value here, which is the coefficient of x, and c is our constant value on the end without any sort of variable value attached to it. So then from here, what's difficult about standard form is unlike vertex form where we can see how the graph moves using h and k. So in vertex form, we were able to use h and k to find our vertex. It's not so simple with standard form. And we actually have an equation here that's going to help us calculate our axis of symmetry. So our equation for the axis of symmetry for standard form. And that equation is going to be x is equal to negative b. So we would take this b value here, and that's our opposite of b. That's what that negative really means. So opposite b divided by 2 times a. And we'll use that equation whenever we have standard forms. Notice a and b come right out of the equation. And we'll use that in order to calculate our axis of symmetry algebraically. So before we start to graph these, we're going to actually identify the axis of symmetry for each of these functions that are written in standard form. And remember, we're going to use the equation x equals negative b over 2 times a, or x equals opposite b over 2a. So what we're going to start off doing is for each one, we're going to identify a, b, and c. So a is our coefficient of x squared, so this is a is equal to 3. B is our coefficient of that middle term with an x, so we have b is equal to negative 12, and c is equal to this constant on the end of 5. So our equation only needs the values for b and a. So here we have the equation x is equal to negative b, or opposite b, so we take negative 12 and we turn it to its opposite, which is 12, over 2 times a, which is 3. So then we need to simplify this to find our axis of symmetry. So we end up with 12 over 6, which is then equal to 2. So our axis of symmetry for the equation in part A is x is equal to 2. Then if we move on to example B, we have our a value, which is the coefficient of x squared, which is a negative 1. Our b value, which is the coefficient of x here, which is 10. And our c value, which is the constant at the end, which is non-existent, or just 0. So we only need our b and a values in order to calculate our axis of symmetry. So we have x equals negative b, or opposite of b, so it's a negative 10, over 2 times a, which is negative 1. So here we have negative 10 over negative 2. Negative over a negative gives me a positive. So my axis of symmetry here would be x is equal to 5. Then if we move down to example C, we have a is equal to, we have negative 8. B is equal to the coefficient of x, which is 4. And c is equal to this constant here, which is negative 5. So to calculate our axis of symmetry, we have x is equal to opposite b, which is negative 4, over 2 times a, which is negative 8. So here we have negative 4 over 2 times negative 8 is negative 16. Negative over a negative is a positive, and this fraction simplifies to 1/4. So our axis of symmetry here is x is equal to 1/4. So you can see here that there are times where our axis of symmetry is not a nice number and a fraction. It doesn't happen very often, but it is in fact possible. And then our last example here, we have an a value equal to 1, because that's the coefficient of x squared. This one, I'm going to pause and slow down for a second, can be pretty tricky because we actually don't have a b value in here. So normally we have plus b times x, but because there's no x value here, we actually have a b value equal to 0, and then a c value equal to negative 16. So just make sure you slow down as you encounter these ones mixing that x term in the middle, they have a b value of 0. So then here our axis of symmetry is x equals opposite b, which is opposite of 0, over 2 times 1, which is our a value. So this becomes 0 over 2, which is equal to 0. So our axis of symmetry here is just x is equal to 0. So let's start this off by giving this a try. So if we take a look, we can see that we have a quadratic, and this one is written in standard form because everything's multiplied out and we don't have any parentheses. So in order to start graphing anything in standard form, we need to find the axis of symmetry. And remember, your axis of symmetry is found by taking x is equal to negative b, or opposite b, over 2 times a. And here we can see a is equal to negative 2, b is equal to negative 8, and c is equal to 2. And so we're going to start off by taking negative 8, or negative of negative 8, which is a little confusing. So it's really negative 8 over 2 times negative 2. Well, the opposite of negative 8, or negative 8, is positive 8, over, this is negative 4. And so we find that our axis of symmetry is that x is equal to negative 2. And we know that this is the middle of our graph. So now from here, we can actually start working towards finding our vertex as well as other points. The first thing we need to note is that our axis of symmetry goes in the middle of our graph. So we're going to put that x value right in the middle. We also know that the vertex contains this x value from our axis of symmetry, which is negative 2. So there's a lot of relationships that we can look at there. So now the next thing we have to do is we have to just plug in different points for x and solve for y. So I'm going to start with the vertex because I like to do that point first. And I'm going to take negative 2, and wherever there's an x, I'm going to replace it with negative 2. And I'm going to plug this into my calculator directly as is. So negative 2 parenthesis negative 2 squared minus 8 parenthesis negative 2 plus 2. Notice that my negative 2's that I've put in for x are surrounded by parentheses. And as I do this, I find that the y value is 10. So I know that my vertex is occurring when x is negative 2 and y is 10. Then from here, I'm just going to find x values that are around, so I have negative 3 here and negative 4, that are around negative 2. And again, go through that same process. So just plugging in those x values to find what the corresponding y value would be. So for this one, it's 2. And you will probably take a little bit more time to calculate these, but again, you're just plugging in, so that's a negative 1, sorry. You're just plugging in those x values to find what their corresponding y values will be. And if you continue to plug all of these in and you take the time to do that, you'll find that if you plug in your negative 3, that also ends up to be 8, so we get some confirmation that this is symmetrical. And if we plug in negative 4, we also find that this one is 2. So this just comes down to plugging it into your calculator and plotting those points. So we can see we have a good estimate of where our graph is going to be. Now, the next thing we need to find is our y-intercept, and we know that that occurs when x is equal to 0. Sometimes, like this time, it appears in our table, and other times we have to plug x equals 0 into the equation. So if you didn't have it already right here when x was 0, you would just plug 0 in and calculate it and find that your y-intercept is when x is 0, y is 2. And that's where we cross this x, or this y, excuse me, intercept. Our domain, we can see, is all real numbers. Our range, we can see, is y is less than or equal to 10, because it's at 10 and then goes down. We can see that our vertex is a maximum point, and so the last thing we need to do here is we need to calculate our x-intercept points. And what we need to remember about our x-intercept points is those occur when y is equal to 0. So what we're going to do is we're going to plug 0 in for y. So we have 0 equals negative 2x squared minus 8x plus 2. And then we have to think through what quadratic solving strategies we want to use to solve this. Because this is written out in standard form, I like to use the quadratic formula. So we have x is equal to negative b, which is a positive 8, plus or minus the square root of negative 8 squared minus 4 times our a value of negative 2 times c, all over 2 times negative 2. That then equals x plus or minus the square root of, if we take negative 8 squared minus 4 times negative 2 times 2, we find 80 underneath that square root. And now we could leave this like this, but because we're actually finding x values here, I'm going to actually break this up and square root that 80. So if I square root 80 here, I find that I have 8.94 after that square root has taken place. And then from here, I can split this up further. I can take 8 plus 8.94 and divide it by the negative 4. And once I do that, I find negative 4.24, which you can see is about right there. And then if I move this over a little bit, I can also do 8 minus 8.94 and divide it by negative 4, which gives me about a positive 0.24, which I can see is about right there. So getting those two x-intercepts, I have negative 4.24, comma 0, and positive 0.24, comma 0. So we can use our quadratic solving strategies to help us find these x-intercept points.